18 years in the production system, I have seen databases go down, cluster fails, deployment wipes, environments, but this one still bothers me. One developer, one test file, one API key. Sitting in a public GitHub repository for 11 days. Nobody set off an alarm, no security dashboard. We found out from an invoice $23,000 charged to our cloud account by bots across 6 countries, 4,200 hits on one key. My name is Samadhan, and this channel, bit by bit, exists for exactly this moment. Complex ops problems broken down so you never have to learn them the expensive way. In this video, I'm going to show you exactly what happened, the war room conversation, the investigation, the moment we found the key, and then two layers of defense that would have stopped it completely before the commit ever left the developer's machine. An API key sitting in the public GitHub repository. For 11 days, nobody panicked, nobody got an alert, nobody even knew it. Bots found it in hours, in minutes. By the time we discovered it, the cloud bill was $23,000. Today, I want to show you exactly what happened and then three things that would have stopped it completely before the commit ever left the developer's machine. The incident. So, the developer, not someone careless, not an intern, a solid engineer moving fast on the feature. They hard coded an AWS key into a test file. They told themselves, I'll remove it before I push. They forgot. The repo was public, a demo, not the main code base, just a side project. Nobody had looked at it in weeks. Here is the number that should change how you think about this. The average time between secret hitting a public repo and a bot accessing it is 3 minutes. 3 minutes, not worst case, average. But the time that developer made a coffee after pushing, bots had already found the key, cloned it, and started spinning up workloads in our cloud account. The war room. I got a call at 9 in the morning. Cloud billing alert, unusual uses. I pulled up the cost explorer and the graph was just going straight up like a wall. We got the team on the call and asked the developer, when did you last push to that repo? Yesterday? No, wait. 11 days ago. I pushed a test file 11 days ago. That was the developer's answer. Did that file have credentials in it? Developer said yes. The silence on the call. You know that one? Where everyone is doing the maths at the same time. 4,200 hits, 14 IPs, 6 countries. This was not a person, this was automated. Updates from the SecOps, the SRE team. We revoked the key immediately, filed a support case, they refunded 18,000. The remaining 5,000, that was the tuition fee. The system failed, not the person, and fixing the system takes 15 minutes. So conventional secret detection with the CI/CD. So when feature branch is created, developer A pushes the code secrets into the directory. It detected by the Jenkins pipeline, integrated with the security tools, and build is failed. Cannot revert it. Okay. Possibility. Meantime, another developer already cloned that branch and the secret flow into another branches before cleanup. Zero automated visibility of detected secrets, cleanups, status. So everything is like reactive rather than proactive. Let's see how we can proactively block this. There are three layers. First one is the Git secret. Git secret is built by AWS Lab. It is free, open source, and sits between your brain and your Git push and checks every file you commit for anything that looks like a credential. I am demonstrating this through the live example. So here we are creating a repo that is called git-secrets demo. I'm just making it public because I'm using the public GitHub. So all the security versions, security functionalities available on the public repos if you have the public account. For the enterprise, all the features are available. So just cloning this repo on my local so that I can push a code into this repo. So now let's see how we can implement this. I have created another repo which I have put the link into description. So here the step-by-step sample script that you can follow will follow all these steps while executing this demo. So let's clone the git secrets, get into git secrets folder, the repo that we have cloned. Create a directory at your local uh, as a bin and copy the git secret folder into bin. We are making it executable. Let's get into the git secret demo repository where we have created the new uh, git secrets installed. It will install all the secrets from the git secrets repo, register the secrets, so that is the register -AWS. Now config at the global level as well. So whatever are the default secrets that we have unset, and will specify the specific rules related to our use case. So you can define the regex, you can define the different combinations and add it into the AWS secrets. So this works for any kind of secret. So here I'm using the Azure key that I have created and looks like. So one thing I would like to mention here, GitHub ignores the test secrets. If it is matching pattern with your git secrets patterns, then only GitHub will recognize it as a real secret and it will highlight and block it. Otherwise, it will allow. So just adding the ACR credentials, sample credentials here, and also additional layer that we can add into the secret patterns. So if you want to make it more stronger, you can also use this the specific case that you can define. Git add, it will add it, then commit it. This is blocking. This is your layer 1. So on the developer's machine itself, all the check-ins, all the secrets will be blocked so that it won't be pushed into your public repo. Whatever is the matched pattern and that is prohibited from the push, commit is rejected. That's a half second right there. That is the $23,000 moment. How many of you have running right now on every machine your team uses? If the answer is other than yes, install it tonight. Link is in description. So though developers has the option to bypass it by providing no verify uh, 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 flag, so Git will allow the push into your remote repo. But there is a layer 2, so where you can enable the security in your GitHub repo. So let's see, you can just go to the settings, advanced security, and enable secret protection and push protection. If you enable this, GitHub won't allow anything to be pushed into your repository, even if anyone bypasses it. So I'm trying to push the sample secret. This is not the real, obviously, into Git. And let's see what GitHub prevents me from pushing this into the repo. So here you can see it provides you the three different options. whether it is used in test, it is false positive, or I'll fix it later. So if you select any one of them, then only GitHub will allow you to push that secret, or otherwise it will block completely. So these are the patterns it matches, and once that is matched, it will block the secret from pushing it. So what happens if you have the existing uh, configuration or existing secrets available in your repo? So when you see that and you go to the security and quality, so GitHub will scan your repo. It will highlight how uh, the key is exposed and what is the risk. This is the existing repository I have. I have pushed that earlier before enabling the security. So now it is showing me the publicly. So this is how, this is the layer 2. Layer 3 is the you can use the third party vault like Hashika vault, Azure secrets, or maybe the AWS secrets, where even if anyone try to push into the GitHub from the local, it will block through the Git secrets. But we don't want to take a chance and make that happen at all. So everything will be stored into the secret store or referred by the secret store in every environment. That's the layer 3. So this is the 3-layer defense that we can. 2 layers are extremely in your environment. So layer 1 is the developer machine, where Git secrets pre-commit hook will be executed. It will identify the different keys, and developer will be blocked from pushing the secret. So if there are no secret, it will process further. If secret is found, it will block that secret and reject the commit. So if developer pushes the code by bypass or passing the no verify flag, the layer 2 will come into picture, and it will scan the secret and block the push itself. So everything will be blocked by push. So here layer 3 will be the notifications that we can call it, and also when we use the secret stores, so everything will be blocked at the layer 3 level only. So if you follow this, if you enable this, you are protected. What is the lesson? There are 3 things. Number 1, the developer did not fail, the system failed. Pre-commit hooks are the guardrails. They make the dangerous thing impossible to do by accident. Number 2, you have ever committed a credential in public repo, even for 30 seconds, treat it as compromise. Right now, revoke it, rotate it. Number 3, security is not a big system you build somebody. It is 4 minutes to install Git secrets, 60 seconds to turn on push protection, 10 lines of code to use secret managers. Small things done consistently. That is what resilient systems are built for. So if you have already posted, if it is already happened, what you can do? Revoke the keys immediately. Audit all activity on the key. Remove key from the Git history, even if it is pushed. So these are critical and very high vulnerabilities. Rotate all related credentials. So do not make any credential available in your even commit history or GitHub repo. File a support case for charge dispute. The cloud will refund 70 to 90% when you prove unauthorized uses and document everything. So one mistake cost $23,000. 3 layers that stop it. The system failed, not the person. Even for the 30 seconds, treat it as compromise. Revoke it now. It is 4 minutes to install Git secrets, 60 seconds to enable the push protections. So follow the channel, subscribe the channel for more videos on the war room.